Okay, so this is E1.10, which is parallel and perpendicular lines. I want to refresh you on what parallel and perpendicular mean, and then show how we can use it to find the equation of a line for another line that's either parallel or perpendicular to our original line. Okay? So parallel lines, if you've ever heard of them or been introduced to them, the special quality that they have is that they never intersect. Okay, so that means is they never touch or they never cross. Okay, so they look something like this. The only way that they can never touch or never cross is if they're increasing at the same rate of change. Okay, which means that slopes of parallel lines are the same. Okay, if slopes of parallel lines are the same, then that means if my original slope is, say, 1/2, then my parallel slope is also going to be 1/2. Okay, and the little two lines I just wrote is just shorthand for parallel. Okay, perpendicular lines, on the other hand, do cross, they do intersect, but specifically they intersect at a right angle, or in other words, a 90-degree angle. Okay, so if I have two lines that cross at a 90-degree angle, one example is my x and y axis. They're exactly perpendicular because my x and y axis cross at a perfect 90-degree angle. Okay, but they don't have to be horizontal and vertical lines. Okay, they could be slanted lines, something like this. Okay, as long as the point in which they intersects at exactly a 90-degree angle, they're perpendicular. Okay, now slopes of perpendicular lines are negative, or let's say are opposite reciprocals of one another. Okay, remember, opposite means I change the sign. If it's negative, it becomes positive. If it's positive, it becomes negative. Reciprocal means I flip it upside down. So in other words, if the slope of my original line was, say, 3/4, then my perpendicular slope would be the opposite reciprocal of that. So opposite from positive 3/4 would become negative, and then I would flip it upside down. So it would be negative 4/3. Okay, so if they're parallel, the slopes are the same. If it's perpendicular, the slopes are opposite reciprocals of one another. Okay, so these next few examples, I just want to look at them and see, are they parallel lines, or are they perpendicular lines, or are they neither? Okay, and the way we do that when we're given two lines is we write each line in slope-intercept form. Okay, because notice once it's solved for y, I can just look at the coefficient on my x term and compare my slopes. Okay, and then just state whether they are. Okay, so remember, parallel slopes are the same, perpendicular slopes are opposite reciprocals, and neither is anything else. Everything else falls into the neither category. Okay, so if you end up with a slope of like 2 and -9, those would just be neither. Okay, so let's look at this first one. This first one, we're determining if they're parallel, perpendicular, or neither. So I want to get them into slope-intercept form by solving them for y. So this first one, I'm going to go ahead and write down here. And notice my y is on this side. So I'm going to flip this equation when I rewrite it, because I like my y to be on the right-hand side. I'm sorry, the left-hand side. So I have y minus 1 is equal to 8/5 times the quantity x minus 1. So I'm going to go ahead and work this out. If I distribute the 8/5, I get y minus 1 is equal to 8/5 x minus 8/5. And then I'm going to move the 1 over. Now, I'm only looking for the slope of this line, so I don't actually need to combine my two constant terms, because I don't really care what the equation is. I only care about my slope. But for the sake of getting some practice, I'll go ahead and combine them. Okay, I need a common denominator here in order to combine negative 8/5 and 1, which I can write as 1 over 1. And my common denominator would be 5. So if I multiply by 5 on top and bottom, I get y is equal to 8/5 x minus 3/5 when I combine those. Okay, so notice the whole reason I did that was just to figure out what this slope is. And if I look at the coefficient of my x term, the slope of this line is 8/5. Then I look at my second line. Now my second line has already been solved for y, so that's the best case scenario, right? I don't have to do any work. So I just look at the coefficient of my x term and notice it's also 8/5. So my slope here is 8/5, and anytime my slopes are the same, that means these two lines are parallel. Okay, I'm going to put here same slope, so that gives me parallel lines. Okay. All right, so let's look at another one. All right, I want to do the same thing, determine if they're parallel, perpendicular, or neither. So I have to make sure both of them are solved for y. When I look at this first one, I have 3x plus 6y equals negative 55. So I'm going to move my 3x term to the other side by subtracting. So I get 6y is equal to negative 3x minus 55. And then I'm going to divide off my coefficient of 6 from every term. So I end up with y is equal to, when I reduce 3/6, I end up with negative 1/2 x minus 55 over 6. So if I look at the slope of this first line, notice it's negative 1/2. Okay. So then I want to look at the slope of my second line. I have y is equal to 2x plus 5 over 3. So it's already in slope-intercept form, so I just look at my slope. Here, my slope is 2, or I can write that as 2 over 1. So notice when I compare my slopes, I have a negative 1/2 and a positive 2 over 1. So that means that my slopes are opposite reciprocals. And if they're opposite reciprocals, that means that my lines are perpendicular. Okay, so I'm going to go ahead and write down here. Perpendicular lines. Okay, not too bad. Let's look at one more. On this next one, I want to determine if these two lines are perpendicular, parallel, or neither. So again, I need to make sure that they're both solved for y. Now notice this first one, I have y equals 1/2. So it's already solved for y, but notice I don't have an x term. If I don't have an x term, the only way that that happens is if I had a 0 as a coefficient. Okay, so that means the slope of this line is 0 because I don't have an x term. Now, as a side note, I want to go ahead and note, just like before, anytime we have a 0 slope, that means this is what kind of a line? Horizontal. Okay, 0 slopes mean we have a horizontal line. Okay, so if I were to graph this, I would have something that looks like that, right? A straight line through y equals 1/2. So I need to determine if this next line is parallel, perpendicular, or neither. So I'm going to go ahead and solve it for y and bring it over here. So I have negative 2y is equal to negative x. Oh, I'm sorry, I wrote it wrong. Let me try that again. Negative 2y minus x equals 9. I'm going to move my x term over by adding it. So I have negative 2y is equal to x plus 9, and then I divide off my negative 2 from every term. So I get y equals negative 1/2 x minus 9/2. So notice if I look at my slope here, my slope is negative 1/2. So if I compare my 0 slope and my negative 1/2 slope, okay, notice they're not related. Okay, I'm just going to write down here, slopes not related at all. Okay, so that means that these two lines are neither parallel nor perpendicular. Okay, now I do want to go ahead and note, remember we had a horizontal line. So if these two lines were to be horizontal, the second line would also have to only have a number and a y, right? It would have to look like y equals something. So I'm going to go ahead and say over here, for these two lines to be parallel, the second line, whoops, the second line would have to be of the form y equals some number, right? It would have to look something like this, right? Or it could be down in the negative y's. But in order for this line that goes straight through a y value to have a parallel line, they would both have to go through y values, right? So notice on this one, since I have x's and y's on my second equation, there's no way that x is randomly going to go away, and I'm just going to have y equals some number. So they're not parallel. And then I also want to highlight that in order for them to be perpendicular, okay, for these two lines, to be perpendicular, the second line would have to be of the form what? Okay, let's think about it. If parallel means they go like this and they never cross, and they're both going through y values, for it to be a perpendicular line, it would have to be going like this, right? So if it needs to go like this, this would have to be a vertical line. In order to get a vertical line, equations of straight up vertical lines go through x values. So in order for these two lines to be perpendicular, the second equation would have to look something like x equals some number, right? So that we could get an equation that looks like this. I'm sorry, a line that looks like a straight vertical line. So really, anytime one of your lines only has one variable, if the other line has two variables, you know right away it's not going to be parallel or perpendicular. In order for it to be parallel, it would have to also be a one variable line, and it would have to be the same variable as your first line. In order for them to be perpendicular, it would have to be a one variable line, and it would have to be the opposite variable that's equal to a number. Okay, does that make sense? Okay, so we want to go ahead and move on. The next thing we're going to do is we're going to find the equation of a line that's either parallel or perpendicular to another line. So in your homework, they're going to just give you a line, and we're going to reference that line. So we're going to use the line that they give you to figure out what our slope needs to be. So whatever line they give you, the first thing we want to do is solve for it, solve for y, so that it's in y equals mx plus b. So then we can see the slope of that line that we're supposed to use. Okay, once we know the slope of that line, if we want a line that's parallel to that one, then we use the same slope. Okay, if we want an equation of a line that's perpendicular to the line that they gave us, then we use the opposite reciprocal slope. Okay, and then once we know our slope, we use that slope and a point that they'll give us, and we'll plug it into the point slope formula, which remember is y minus y1 is equal to m times x minus x1. Okay, and then once we do that, then we just simplify and write our answer back in slope-intercept form, which means once we plug it in, we simplify and solve for y. So let's go ahead and look at an example. This first one, it says, find the equation of the line that is parallel to this given line and passing through the point -5, 0. So the first thing I want to do is solve for y to see the slope. Okay, so I'm going to take this equation and I'm going to go ahead and solve it for y so I can see what is the slope of this line. Okay, so I'm going to go ahead and do y plus 3 is equal to, now I'm going to distribute this -1/10 as I'm writing it. So -1/10 times x is -1/10 x. -1/10 times -2 is +2/10, and then that reduces, right? So I have y plus 3 is equal to -1/10 x plus 1/5, and then I need to subtract my 3. Now again, I don't really have to work this out because I'm only concerned about my slope. So I'm just going to say y equals -1/10 x, and then over here this is going to be some number. Okay, but I don't care what that number is, because all I care about is what is the slope of this line. So notice the slope of this line is -1/10. So I go back up to my problem and it says my new line is going to be parallel to this one. So if it's parallel, then my parallel slope should be the same. Okay, so here my parallel slope is also going to be 1/10. So now I know the slope that I'm using, and so I'm going to use that slope and the point that they gave me and plug it into my point slope formula. So I do y minus y1 is equal to m times x minus x1. So I do y minus the y from the point that they gave me, which is 0, is equal to the slope, which I found using the other line, which is negative 1/10, times x minus the x that they gave me, which is negative 5. Y minus 0 is just y. Negative 1/10 times x. Oh, let me go ahead and simplify the double negatives. X plus 5. And then I'll go ahead and distribute that negative 1/10. So negative 1/10 times x is negative 1/10 x. Negative 1/10 times 5 is negative 5/10. And then I'm going to reduce that. So I have y is equal to negative 1/10 x minus 1/2. Excuse me. So this is the equation of the line that is parallel to the line that they gave us and that goes through the point that they gave us. Okay, so we use the line they gave us to find the slope. If it's a parallel line, we use the same slope. If it's perpendicular, we use opposite reciprocal. Once we have that slope, we use that slope and the point that they gave us and plug it into the formula just like we were doing before. Okay, so we're only adding on one step, which is that we have to use the line they gave us to find the slope. So let's look at another one. I'll do one and then I'll have y'all try some. So one more. This one says, find the equation of the line that is perpendicular to this given line. So the first thing I want to do is I want to take this line and I want to solve it for y so that I can see what its slope is. So I'm going to move my 3x to the other side by subtracting. So I get 3y is equal to negative 3x minus 1, and then I divide off my 3. So I get y is equal to, negative 1x, or just negative x, minus 1/3. So I'm looking for the slope here. The slope of this line is negative 1, and notice I want the perpendicular slope. So if I want the perpendicular slope, then that means I have to do the opposite reciprocal. Okay, so since my slope is negative 1, if I were to write that as a fraction, that's the same as negative 1 over 1. So to find the perpendicular slope, I do the opposite reciprocal. So I'm going to change it from a negative to a positive, and then I'm going to flip it upside down, which if I flip it upside down, I still get 1 over 1, which is still just a positive 1. So that means that my perpendicular slope is 1. So now that I know what my slope is that I need to use for my line, then I look to see what point they gave me, which is here 2, negative 8, and I'm going to plug those into my point slope formula, which is y minus y1 is equal to m times x minus x1. Okay? So I do y minus the y that they gave me, which is negative 8, is equal to my slope, which is 1, times x minus the x that they gave me, which is 2. My double negatives here become positive. If I distribute the 1, I get x minus 2, and then I just need to move my 8 to the other side. So I end up with y is equal to x minus 10. And this is the equation of the line in slope-intercept form that passes through the point 2, negative 8 and is perpendicular to the line they gave me. Okay. All right. So on the next the end of this page and the next page, there's 3 for y'all to try. I'll give you a minute to work on those, and then we'll go over them. Okay. All right, so this first one, it's just asking if the two lines are parallel. It's not asking if they're parallel, perpendicular, neither. They're asking specifically, are these parallel? So in order for them to be parallel, that means they would have to have the same slope, which if you notice, when we solve both equations for y, and we look at their slope, which is the coefficient on the x, we have a slope of negative 1/4 and a slope of negative 4, which since these are not the same, then they are not parallel lines. Okay, so you can just say nope, or neat, or whatever, 9. Okay, so the second one, we're looking for the equation of the line that is parallel, meaning same slope, to this given line and passing through the point 3, negative 2. So we take the line that they give us and solve it for y. Once we get it solved for y, you'll notice that our slope is 3. I've highlighted here we want the parallel line, so that means our parallel slope will also be 3. So now I take my parallel slope, which is 3, the point that they gave me, which is 3, negative 2, and I plug it into my point slope formula. Okay? When I plug everything in and solve for y, I end up with y is equal to 3x minus 11, which is the equation of the line that is parallel to the line they gave us and that goes through the point 3, negative 2. Okay? There's one more. The last one, they're asking us to find the equation of the line that is perpendicular, which means we're going to use the opposite reciprocal slope, okay, to this line that they gave us and passing through the point 8, 5. So we take the line that they gave us, which is 5x plus y equals 10. We solve it for y, which means that the slope of that line is negative 5. Now we don't want to use negative 5 because our line is perpendicular to this line, which means our slope should be the opposite reciprocal. So instead of negative 5, I'm going to make it positive, and then I flip it upside down. Remember, 5 is the same as 5 over 1, so when I flip it, it becomes 1 over 5. So my perpendicular slope is 1/5. So I'm going to use my perpendicular slope of 1/5 and the point that they gave us, which is 8, 5, and plug it into my point slope formula. Okay, once I plug everything in and simplify, notice when I move my constant term over, I will need a common denominator. Once I've combined my two constant terms, we should end up with the equation y equals 1/5 x plus 17/5. So this is the equation of the line that is perpendicular to the line they gave us and that goes through the given point, 8, 5. Okay? All right, I think I have one more to show you. Yes. So on this one, we want to find the equation of the line that is perpendicular to the graphed line through the given point. So this is exactly the same as what we just did. What we did before, excuse me, is we were given the equation of the line and we used it to find the slope, and then we figured out what our perpendicular or parallel slope would be and we plugged it in. The only difference here is instead of them giving us the equation of the line, they're just giving us the actual line. Now remember, the only reason we care about the equation of the line is to figure out what the slope of that line is. But since I don't have the equation, I can just find points on this line and count my slope. So I'm going to look at this, this line, and I'm going to find places where it crosses exactly through the corners of these boxes, which it looks like this is one maybe, and this is one, and this is one. Okay, I'm just going to find these, and then I'm going to count my rise over run. Okay, so if I start at, say, this point on the x-axis, and I count up to my next point, okay, that gives me my rise. My rise, I'm going up 1, 2, 3. So for my slope, I'm going to say from graphed line, my slope, which is my rise over my run. My rise is a positive 3, and then my run, if I count how far I'm going from this point over to my next point, is a run of 2. So I'm rising 3, I'm running 2, which means that my slope for this line is 3/2. Okay, so I look at my problem, we want perpendicular slope. So if it's perpendicular slope, that means we want the opposite reciprocal. So for my perpendicular slope, I'm going to flip 3/2 upside down and make it negative, which means my perpendicular slope is negative 2/3. So I'm going to use negative 2/3 and the point that they gave me, which I need to figure out what that point is. So I'm going to count. On my x-axis, I'm going forwards 2. On my y-axis, I'm going up 2. So this is the point 2, 2. So they gave us the point 2, 2. And I'm going to use that point and my perpendicular slope and plug it into y minus y1 is equal to m times x minus x1. So y minus the y from my point, which is 2, is equal to my slope, which is negative 2/3, times x minus my x point, which is 2. So So I go ahead and distribute my negative 2/3, which gives me negative 2/3 x plus 4/3. And then I'm going to move my 2 to the other side by adding. Okay. So I end up with y is equal to negative 2/3 x. Now, in order to combine these next two terms, I need a common denominator. Remember, 2 is the same as 2 over 1. So my common denominator would be 3. So I'm going to go ahead and just multiply by 3 on top and bottom of my second one, which gives me y is equal to negative 2/3 x plus 4/3 plus 6/3. So my equation, when I combine my constant terms, is y is equal to negative 2/3 x plus 10/3. Okay. So this is the equation of the line that is perpendicular to the line that's graphed and that goes through this point. So what I want to go ahead and do is I want to just go ahead and graph this line. Graph in pink. So notice if I wanted to have the line that goes, whoops, I didn't draw that very well. But this is the line that is perpendicular to my graphed line and goes through the point 2, 2. Okay, so notice these lines cross at a 90-degree angle. Okay. So the other thing that I want to look for is it says on here, how far is the plotted point from the graphed line? So now I'm looking for a distance. Remember distance? So I want to go ahead and put my distance formula up here, which hopefully we remember. Our distance formula is the square root of x2 minus x1 squared plus y2 minus y1 squared. So I need 2 points in order to do this, and to find how far the plotted point is from the graphed line, I'm going from the plotted point to the point where it intersects, which is right here where my pink line crosses that blue dot. And that point on the graph is 1, 2, 3, 4, 5. This is the point 5, 0. So I'm going to use the point 2, 2 and the point 5, 0 as my points. Okay, so I'm going to go ahead and plug them in. So I have the square root of my second x value, which here is 5, minus my first x value, which is 2 squared, plus my second y value, which is 0, minus my first y value, which is 2 squared. So I have the square root of 3 squared plus negative 2 squared, which gives me the square root of 9 plus 4, excuse me, which gives me the square root of 13. And then again, we can leave it like that because the square root of 13 doesn't simplify. That's our exact answer. If we wanted to get a decimal answer, we could approximate to the nearest hundredth or so. So let me go ahead and get a decimal answer. If I do the square root, whoops, if I do the square root of 13, where's my square root button? There it is. I get 3.605. So I'm going to round that to 2 decimal places. So we're just going to say 3.61. Okay, so that means my distance is equal to the square root of 13 or the same as 3.61 approximately. Okay, so we know that our line that's graphed here is perpendicular, and the distance from that point to the center point of this line over here that's in blue is a distance of 3.61. Now the last part says reflect the point to the opposite side of the graphed line. What is its ordered pair? So we're taking this plotted point. I'm going to go ahead and erase some of this so that's a little bit easier to see. Okay, so what they're asking me to do is to take this point, this black point 2, 2, and reflect it to the other side over here. So I'm just going to count my slope. Notice going from my black point down to my blue point, I'm going down 2, forwards 1, 2, 3. So again, I'm going to go down 2, forwards 1, 2, 3. Here's my reflected point, which is a little sad because that means that my pink line was not very straight. So So let me redraw my pink line and see if I can make it go through these 3 points. Okay. All right, so they had me reflect that point over, and they just want to know what's its ordered pair. So if I look at the ordered pair that corresponds to this orange point, my x value is 1, 2, 3, 4, 5, 6, 7, 8. And my y value is -2. So I'm just going to put down here, the ordered pair is 8, -2. Okay. And then I'm just going to put a note, or I think I already put the note down here. The shortest distance between a point and a line is where the new line crosses the given line at a 90-degree angle. This is called the perpendicular bisector. Okay, so sometimes I'll ask for the perpendicular bisector, which is basically just the distance between the given point and the line when it intersects. Okay, so the distance that we found was this distance right here, was the square root of 13. Okay. All right, so that is the end of E1.10, which is our parallel and perpendicular lines. That one you can now complete in your homework. And E1.10 also has a worksheet. Okay, so make sure you do the My Math Lab homework assignment and you do the worksheet that goes with E1.10. It's located under your course materials tab, and there's a sub tab called worksheets, and you'll see the E1.10 worksheet, which you'll need to work out by hand and either scan and email it to me, fax it to me, or I don't know, take a picture of it with your phone and email it to me. Either way, make sure it gets to me by the due date. Okay, let me know if you have questions.